You will learn how to measure using indirect measuring to measure across a river or other body of objects that we're not able to measure across. And this um, person here is on one side of the river. It is not able to, or she is not able to move across the river. There's no boat, there's no rocks to throw, there's no way to measure, or even if you could get a measuring tape across the way, the river would actually take the measuring tape, and pull it down, and it wouldn't be a very good measure. So, this method of indirect measure helps us to be able to accurately measure the distance across. And this is what they used to use before technology of lasers and everything. They all, like through history, this is how they made bridges and knew how much material to have on hand to build that bridge across, and how many supports they needed, so they could plan all these things before they started building it. So what this person did was build a triangle, put a point here, walked down the beach or river's edge to another point at C, put a marker, usually like an orange flag or something, and then continued on a straight line all the way to some other point down here. Then they measured a right angle and walked out some distance, and when they looked back, they would have measured a point that was actually across the river at a 90-degree angle here also from where they started, and then they would line up. So let's say they had like a log or a big rock or something or a stump that they could kind of measure or sight from farther away. So they would walk down and then line up where they were standing with the marker that they had made previously, and in line with across the river. And that would make two triangles. Now, what we have to do though first is we have to explain why those two triangles are similar. So to do that, we need to look for, remember, two angles that are the same, because if two angles are the same, then therefore the third angle is the same. So right off the bat, we can see we have two right angles. And those are given for us because we use those in those measurements to find that. So we can say angle B is congruent to angle E, and we can use the shortcut ones because there's no other main kind of issues with. We know that angle E, there's only one angle E, and those are either the given, or I like that they're 90 degrees each, or you could use the word right angles to identify why they are the same. So what we're looking at here is evidence first. So we're looking for the evidence first before we write our reasoning. So we've got one angles of our triangles that are equivalent or congruent. So now we need the other ones. And I kind of look here and I see two crossing lines. So I'm thinking to myself, oh, this angle and this angle are vertical. So I'm going to write my vocabulary word, vertical angles. Now I need to name them. And notice, remember, in the last video, we talked about that we can't name it angle C and angle C because there's 4 angle C's, and if you name it C and C, we don't know which of the 4 you're talking about. I know you can point to them, but remember, we're writing them. So here's where we have to use that more complicated one where there's 3 of those angles. So I notice that the C is for both of them. So I'm going to put C in the middle. And to make it a little easier, since I can find my right angle easier, I'm going to start at B. So I'm going to go B, angle B to C, out to A. So that's going to be my order. Now, to get them in the right order over here, I kind of want to put them in that same kind of starting with C in the middle, because they kind of have the same C middle point. So I'm going to start here at my right angle is E. So I'll start with angle E, C. So E to C out to D. So now that I've got my two angles, I can state that triangle BCA. I know most people want to go ABC, but I'm going to go BCA because I was looking right here at this group because that's already written in the same order as this one. I already spent that hard thinking time, and I'm just going to copy it now. So triangle BCA and triangle ECD are similar, so we've proven that they are similar. And then we have to give the reason. Because they have two pairs of corresponding angles. Therefore, the third angles are also congruent. So now that we have our reasoning and we've proven that the triangles are similar, we can now go to solving for what is the distance across. So I'm going to do that in red here. So I notice that BC, and I'm going to start with this one because I know these two. So I like to circle all my numbers because those are the numbers we're going to be using, and our x, which is also a number. So I noticed that BC is congruent when I did my evidence up here, is congruent to the 40 because it's the same corresponding side as EC. So when I wrote that angle right here, BC is the same as EC. So that means that the 60 corresponds with the x. So now I can either set it up as a proportion with my equals, so 50 over 40, and the bigger triangle of 50 goes with the 60, so we have to get them in the right places, goes along with the x in that smaller triangle. And then we can use our cross products. Now for me, I find that a little bit more challenging because it gets bigger numbers. So what I like to use is that scale factor. So looking at from 40 to or 50 to 40, I don't have to go searching very far. I can just look for my multiplier, which will be 50 and 40. So I'm thinking to myself, because I just have to use the 50 and the 40 numbers. So I just have to think I'm going from 50, which is a bigger number, to a smaller number. So I'm going to put the 40 with my number sense. I know I have to put the 40 on the top and 50. So if I multiply by a smaller number fraction, I will get a smaller number. If I had put the 50 on the top and the 40 on the bottom, I would be going the other direction. My multiplier would start at the 40 going up to the 50. So now I could just simplify. Oh, I can see that I can simplify a 10 out of each of those. So that would be my multiplier of 4/5. So that means over here it will be the same multiplier because our triangles are similar. So our multiplier will be times 4/5. So we're going to look at start at 60, multiply by 4/5, and that will be our x. So 60 times 4/5 will equal our distance. So I'll make them both fractions to multiply across. I see that 5 goes into 5 once. 5 goes into 60 12 times, simplifying before I multiply. And then 12 times 4 is 48. And I don't forget that it's kind of a word problem, so we need 48 feet is our answer. Now we could do that same thing with cross products here for our um, proportion. So that would be 50x equals 40 times 60. Ooh, some big math here. So that'd be 2400 equals 50x. Divide by all sides by 50. And I have a big number here that I have to simplify. 10 can cancel out with 10, simplifying. 5 goes into 240, and you'll never guess what, it's 48. So x equals 48 feet. So do you see how it works nicer with the nicer numbers? We can simplify, and it gets us the same answer.